It's time to add balances, rollover, and a dedicated view for the months of a budget. This video is part of a series where I'm building a Phoenix app from scratch, and as always, the code is on GitHub with a link in the description. Let's get into it. Last episode, we introduced the concept of budget periods. They're created alongside a budget, but they don't really do anything. Let's change that by creating a new LiveView, and we'll call it periodshowlive.ex. And I'll paste in an initial implementation. As with most live views, we're also going to need a template file, which will be periodshowlive.html.heeks, which is an HTML embedded elixir. And there is the template. Now, finally, I'll add an entry into our router, which is in router.ex. This way, the route will know that it needs to go to this specific live view. In this case, we're going to be at /budgets, /budget ID, /periods, and then the ID of that budget period. Now we can add a link to navigate to this page in our budget show live HTML Heeks template. So instead of these divs, we can make them into links to that budget period display page. Let's walk through the initial implementation just to see what we'll be working with. So we're going to get a budget period considering the current user and a budget ID. And down here, we're going to pull in the transactions. And then over in the view, we are going to display the budget name, display the budget period. And actually, we've got an error here on transaction amount. And that's because this component was declared in a previous episode directly in budget show live. So what we can do is pull these components out, that is currency and transaction amount, and put them into our core components file. And I'll add it just before the JavaScript commands. So if I click on this January period link now, it'll take me to the page for that specific period, but it's going to crash. Specifically because the getBudgetPeriod function doesn't exist in the tracking module. But we can fix that. So if we go into the tracking module and go toward the end here, we can paste in an initial implementation. Now the way this function should work is that we have a budget period with a specific ID, and then we're going to use the criteria pattern that we explored before to construct a query based on some keyword arguments. In this case, we want to be able to look at the user to make sure we're not exposing a period to somebody who doesn't have access to the underlying budget. We're going to pull in the budget ID to help us scope things in, and the preload so that we can add associated properties without having to issue extra queries and extra calls. Going back to the page, it's no longer crashed, and in fact, it's pulling up all of these transactions. Wait a minute, this is supposed to represent the January period, and yet I see transactions from February, from March, and so on. Let's take a look at the call that we're making to pull the transactions. In period show live, we're calling list transactions, and our intention is to query where the date is between the start date and the end date of the period. But if we go into the list transactions function and see that it defers to transaction query, there is no case for this special between operation. Now, one implementation of this could be written with a less than and greater than date comparison, but Postgres has an operation called between. A between query isn't necessarily more performant, but it more clearly articulates what we're trying to achieve. But it's not directly supported in Ecto. When we need to access some SQL syntax that's not already supported in query methods, we can break out to fragment. More than just string construction, it handles sanitization and binding to make sure we won't hit any SQL injection vulnerabilities. Let's see what that looks like. Here's an alternate implementation of between. In this case, we take the query, we say that it must have an effective date that is between the start date and the end date. So I'll remove this older implementation because this is much more clear from a database perspective. Also, it knows that t.effective date is a reference to a field within the query, while start and end dates are variables from the function. Again, it prevents SQL injection attacks because it's still a part of the overall Ecto system. Now, if I go into the page and refresh, I'll only see transactions from that specific period. If I go back and then jump into February, now we only see February, and so on. Now, there was a transaction in March that I wanted to delete. But if I come in and click delete transaction, the page is going to crash. The reason for that is that the delete handler lived in budget show live, and when I moved this over, I didn't add that handler. So if we go into budget show live and scroll down to the delete transaction event handler, we should just be able to grab this and put it directly into period show live.ex. Now, if I want to delete a transaction, I can hit delete transaction and it'll take care of it for us. Now, edit is going to be a little bit more tricky. If I hit this edit button, it'll let me edit the transaction, but behind the scenes, I'm actually on the main budget page. To prepare for this to be handled by the period page, we need to add 2 more routes in our router. So under the period, we should be able to have a new transaction, and we should be able to edit a transaction. This is using the same live action concept that we used on the budget page. Over in our table, we can now say that to edit this transaction, we want to do it in the scope of this period. And if I come in here and edit this transaction, I am taken to periods, period ID, transaction, transaction ID /edit, but nothing's showing up. In period show live, let's add the params and then call an apply action function. Again, this is the same as what we did before. We're just going to be doing it in this view. And whenever we have an action of edit transaction, we want to make sure to load that and set it in the assigns as transaction so that it'll be easy to pass into the modal. Speaking of that modal, let's open up our template file and add the modal. In this case, when we cancel, we want to come back to this single period page, and we want to have the transaction be the transaction from the assigns, as well as the action being the live action from this page. And all of this is delegating to our existing transaction dialog, which will still be in use on the budget page when we create a new transaction. We should be able to come in here and edit the transaction, and let's set it to 111.01, save it, and, well, we're taken back to the budget page, but we do have 111.01 spent here. We'll fix up that navigation in a moment, but I want to add another button here. There's no clear way to add a transaction to this budget period, but it's easy enough. In our template, all the way at the bottom of the list, we can just add a little link to that new transaction page. And now, if I hit this link, I'll be able to create a new transaction. Now we can add a similar button to the bottom of the empty state, which I don't think I've shown you yet. Over in the budget, let's go somewhere kind of far out, and we can see that there's no transactions yet. That's done by this enum.empty check, and if I add a little button down here, now we have the ability to create a transaction from our empty state. But when I create a transaction, and let's just say this is 123 test, and save it, it's going to send me to that main budget page. Let's take a look at how we decide where to go after saving a transaction, which should be in transactiondialog.ex. Inside of our save transaction functions, whether new or edit, we push a navigation to the budget page directly. But we could extract this out into a helper that'll take us to the right place for a given transaction. So let's replace this with a push navigate to the result of a function that we haven't yet written called destination on success. I'll do the same thing down in our edit. Of course, this is going to crash the page. It's not going to compile because, like I said, the function doesn't exist yet. But when it does exist, it'll look something like this, where we're going to find the right time period for that specific transaction that was created, and as a result, we will route directly to that period's page. Now, this is going to require a new utility function that will look up the time period for a transaction, which shouldn't be too hard to implement. If we head over to the tracking context module, we should be able to implement it like this, where we can rely on our existing budget period query function and set this during property to the effective date that we extract out of the transaction. And in the end, we should get one result back. Now, this criterion doesn't yet exist in our budget period query function, but it's easy enough to add with another one of those between fragments, where we're going to say that we want the date to be between the period start date and the period end date. This is also easy enough to test, so we'll go into tracking test and add a new test down here. So given a specific budget and 2 periods, let's create a transaction that is clearly in February and make sure that the period for that transaction is equal to February. If I run the tests, everything comes back green. So if I come in and create a transaction in January, I'll be taken to the January period. And if I edit that transaction, and let's say we're going to move it to February, the result is I will be taken to the February time period. But what happens if I edit one of these and set it to the year 2100? I hit save transaction, the page has crashed, transaction not found, everything is awful. I don't know how I missed this when I added transactions to the app, but there's no validation that transactions are going to be within the budget's time range, which means that there's no guarantee that there will be a time period associated with that transaction. To solve this, we can add a new validator to the transaction change set. So I'll go into budget transaction, and under the change set function, let's add validate transaction date in budget range. So given a change set, let's make sure that the effective date is not before the start date or after the end date. And if there's no effective date, it's fine. We're not validating anything yet. It hasn't been set. And if it is within that range, then we're all good. But let's add those errors must be after the budget's start or before the budget's end in case we're violating those properties. Now I can pipe this change set through this validate function, and well, it's going to need a budget, which means that we're going to need a budget passed into our change set, which is a breaking change. So if I run our tests, this is going to blow up like big time. Looks like we've got 10 failures. And that's because this was a breaking change to our transaction module's change set function. So let's move up to the caller of this function, the tracking context module. Over in tracking, when we create transactions, we've got a little error indicator here. We are just passing the transaction and the attributes. But this can easily be replaced with a slightly different set of functionality. When we create a transaction, let's require a budget to be passed in. When we update a transaction, let's extract the budget out of there, and if we don't have one then, we can also take in a budget as the first argument, but ultimately we can pass that into the changeset function as a separate argument. Now this is going to make budget a required property, so if I run the tests again, we should have still 10 failures, because all of the callers of this tracking module haven't yet been updated. The failures are distributed across multiple files. While most of them are in trackingtest.exs, some of them are in things like LiveView tests. To focus in on exactly what I'm working on right now, I can run mix test with a specific file path to the tests that I actually want to run. Now, there's a few different ways of specifying which tests to run, but this path-based one is the simplest. So there's 6 failures that are directly inside of the tracking context modules tests. To address those, we can head over to trackingtest.exs, and we can replace these such that the budget gets passed in as the first argument. So if I do that here, let's see if we can reduce that number to 5. And for the rest of these, because this will get a little bit tedious, I've actually already got them on my clipboard like any good cooking show. So we'll replace all of these with tests that do pass in the budget correctly, either within the transaction itself or as the first argument when we're calling create. If I run the tests one more time, it all succeeds. And now that the tests are updated, we can figure out what's wrong with the dialog. So in the dialog, when we call create transaction, let's just pass this budget in as the first argument. And similarly, down here, when we call update transaction, let's add that budget. And with those changes made, running mix test returns 0 failures across the entire test set. If I try to create a transaction that is before the time period of the budget, for example, if I do something that is in 2021, we'll see that it has to be after the budgets start. And similarly, if we do something after the budgets end, then it'll be prevented there. It'll also be prevented if we try and hit save. So we can confidently say that we're taken to the right page when we're creating and editing transactions, because we know that they will be within the time period, and we know that we can find that period directly. Save the transaction, and we should be in May. I know that walking through a refactor in that level of detail might not be the most engaging content. Let me know below if you have any feedback. Anyway, this display page is looking really good. So there's no reason to display the transactions in a table at the bottom of the budget page anymore. So let's remove it. We no longer need to list the transactions on the budget show page. We don't need them to be in the assigns, and we don't need this table down at the bottom of the page. By removing that, we can eliminate a query from that page, making it load faster, and we can reduce the memory pressure because we're not really using those transactions, we're just using summaries. But the budget page as it is right now doesn't really do what we need it to. It doesn't tell us how much was spent each month. Am I spending according to my budget month by month, or am I falling behind? Let's extend this page so the user can answer those questions themselves. In the last video, we added a summary of all spending and funding transactions in a budget through a function called summarize budget transactions. We can take a look at its implementation here. This function returns a map of spending and funding decimals across the budget's lifetime. My goal is to get similar details for each period of the budget as well as this top-level summary. I'm going to back into this from a test-driven perspective to show how we can build something that works, and then consider using database features to pull it into a single query. So let's pull up the corresponding test in trackingtest.exs for the summarize budget transactions function. Instead of directly asserting that the response is going to be this object, we can say that we want the result to be a map where the total has that spending and funding value in it. This is easy enough to make succeed by going over to tracking and setting this to total is the result of that query, that map that we had before, and returning total is that map. Now, if we run the tests, they succeed. Now, we can extend the test case to divide the transactions across 2 periods so we can prepare for those more detailed results. As it's written right now, we don't really know about the budget periods at all. So I'm going to copy an implementation of this, This new implementation starts out by establishing January and February, putting some transactions into January that were in there before, and then February having one transaction for spending and one for funding. And then finally, we're going to do some summarizing. And I've updated the totals in the test, so this one should also succeed. And the real magic is we can start asserting that January has the correct total and February has the correct total. Recall that the result of this is going to be a map where total is a special key, and then the ID of each period will be a separate key. So under January's ID, we expect spending to be 5 and funding to be 12. And under February, we expect it to be 11 and 13. Now this one is not going to pass because we're not looking at that detail. All that we're returning is that total object. Now this can definitely be refactored so that we can return that structure. What I'm going to do is take the existing query and call it total query. And then we can do the same thing with the budget periods. Grabbing those period totals, and we'll walk through this query in just a second. And then finally doing a map merge at the end. So I'll show you that this works, and then we'll walk through what it does. It does succeed. What it does is it issues two queries to the database. The base of the query is transactions, and they are then joined by ID and by time, using our favorite fragment between, in order to get bucketed into the right period. So a transaction is joining to a period on the ID, and then on its effective date being between that period's start date and end date. When you're doing joins in a database, it is possible to join on criteria more than just IDs. It's just a little bit less common. From there, we select that we want the period ID, the type, and then the sum of all of the transaction amounts, grouping by that period ID and that type. Then we aggregate that into a map. This is a little bit verbose, but the result of it will be a map that has the key of the ID, and then the value is another map with that type and that amount, very similar to what we did for the totals. Now, this is some pretty messy code, but I love that it has a clear home in the context module so that it doesn't leak throughout the rest of the application. In other architectures, queries and operations like this might end up scattered in models and in controllers. In this case, we have our single entry point into the context of tracking. Now, I want to show you something interesting that's available in Postgres. MySQL has something similar, but not identical, which is probably why it's not directly available in Ecto. It's called grouping sets. Grouping sets are like having multiple group by operations in a single query. Let's take a look by directly querying the database through a command line utility called pSQL. So I'm going to run a query that's pretty similar to the one that we're running right now, where I'm grabbing a sum of amounts and grouping by, in this case, budget ID and type. This query is exactly what you'd expect with a group, where all of the things under a single budget and type end up added up in the sum. But we can extend it to use something called grouping sets. So in addition to grouping by budget ID and type, we're also going to get results where we're just grouping by type. Notice these two new results. With a null budget ID and a type of spending, the result is 1,523. That's the sum of the spending from this budget and the spending from this other budget. You can probably see where I'm going with this. By issuing a single query, we can group multiple ways. We can get some detailed information and something at a higher level. Just to show you a little bit more, and then we can get back to the implementation, there's a special form of this in analytics queries called a rollup. This one adds a complete sum regardless of the budget type. So it runs through all of these different combinations where we've got type and budget ID, then just type, and finally just the overall sum, setting budget ID and type to null. And finally, the most extreme version of this is called cube. It includes all of the permutations of the groupings, including the sum of all transactions grouped by budget, ignoring type. Rollup and cube go beyond what we need in our function, but it's interesting to know that database engines are able to pull these kinds of aggregates if we need them. And of course, this is all available through Fragments. There's also a hex package called Ecto OLAP, but I don't think it's worth pulling in a dependency to just run a couple of simple grouping set operations. So let's see what it would look like to rewrite the function to use grouping sets and get the result more directly. In our tracking module, in our summarize budget transactions function, it could be expressed like this. Swap it out with a new implementation that's a little bit shorter. So just like before, we start out with our transaction. We join to the budget ID and the effective date being in the range of the period. We select the ID, the type, and the sum of the amount, but our group by is going to be this grouping set where the first set is ID and type, and then finally we're going to do by type. When we pull all of this information in, there will be some results where the period ID is null, like we saw a moment ago. And in that case, we're going to call that the total. And then if there is a period ID, then we know that we're updating that period ID directly. And if I run the tests one more time, by issuing a single query to the database, we're able to grab summarization across the period level and the budget level as a whole. Now, this kind of optimization may be overkill for a personal finance app with a very small transaction volume, but consider an application where thousands or even millions of transactions have to be included in the results. Performing multiple queries with different groupings will result in duplicated data access and can either slow an application down or put unnecessary pressure on the database. And now that we have our transaction summaries working efficiently, we can put this data into use by showing users their running balances across periods. If I refresh the budgets page, it's going to come back with 0 as the balance, the funding, and the spending. And that's because I haven't updated that function to understand that we now are scoping things under total and under the budget IDs. So we can swap this out, and instead of saying funding is directly summary.funding, we can swap it with something that looks like this. The getIn function is a nil-safe function to pull data out of nested structures that conform to the access protocol, typically maps. So here we can get the summary.total.funding and summary.total.spending values off of that object and return them at the top. And if I go to the page, I can see that the summaries are back. Now within each period, we can do something similar, where the funding amount is going to be the period ID and funding under summary, and the spent amount will be summary.thatperiodid.spending. So here we could see that we funded $1,000 and spent $111, and then in February, $400 and $304. Down in April, we only spent money. And in June, it looks like we're planning to fund the budget. Finally, we need to show balances for each period. Since our budget will allow for rollovers, the balance of each period is going to be a function of the balance of the previous one. And we can articulate these expectations through a test. If I head into the test folder and add some new stuff at the bottom of our budget show live test, I'll show you what we're expecting. If there's no periods, then we're going to want a map that returns no balances. But say that we have 4 periods. Period 1 has some funding and spending. Period 2 has no activity. Period 3 just has funding, and period 4 just has spending. If we run a new function called calculate ending balances, we'll expect that period 1 has the balance of taking 7 minus 2. Period 2 will have no impact because there were no transactions. Period 3 funds by 5 more, putting us at 10. And period 4 brings us back down by 3 to get us to 7. Now this implementation is going to look a little bit scary, but I'm going to break it down. So at the bottom of Budget Show Live, let's add this function called calculate ending balances. And I can show that it works by running the test. But let's break it down, because if you don't come from a functional programming background, this implementation might be a little unnatural. First, we describe a base case where there are no periods. This helps us avoid out-of-bounds errors later on when we make the assumption that there's at least one item in the list. In the implementation where the list has items, we start out by declaring a local function that can calculate the net value, or funding minus spending, for any given period according to that summary map. Then the weird part starts. Zip, drop, and reduce. Very functional. Let's recreate this with a more simple list to build an understanding of what's going on. So imagine that we have a list of items, 1, 2, 3, and 4. If we run enum.zip with items and items, what we'll get is a list of tuples that zip the two lists together. Enum.zip takes two or more lists, walks through them, and creates a list of tuples with corresponding items from each input list. So by zipping the list to itself, we get 1, 1, 2, 2, 3, 3, 4, 4. Now enum.drop returns a list after skipping the first in items. So if we run enum.drop items 1, we should get 2, 3, and 4. Now each period's balance is a function of the one that came before it. So if we can come up with a structure that gives us the previous and current period, then we can build up that value. So if we take this zip and combine it with drop, then we get the list 1, 2, that is the second period relies on the first, 2, 3, and 3, 4. So if we create a result map that starts out with a balance for 1, we can walk through this list to calculate all of the subsequent items by adding their net value to the previous balance. Visually, that looks something like this. We have those two lists. We're going to drop the first element here, and then we're going to bind these together. So 1 goes to 2, 2 goes to 3, 3 goes to 4, and 4 just gets omitted because there's no more items to zip together. So if we look at the implementation, that's exactly what this does. We set that first period's net value as the starting point for our reduce, and then we walk through that zip, taking the previous period ID and the current period ID, running a decimal add, and putting that into the period. So period 2 is going to take period 1's results and then add to it period 2's net value, and finally put that into the map. What that means for us is that if we go into our mount function, in addition to getting the summary, we can calculate our ending balances and then take those ending balances and put them into the assigns. Now that they're available in a map, we can go into the Heeks template and set the ending balance for a given period to be equal to ending balances dot that period ID. And then somewhere down here, we can display that amount, that running balance, in a currency function. So now we can see that it was 888.99, 984.56, 984.56, and so on. Now, some of these periods haven't happened yet. They're basically projections. Like if I look down here at October, it's interesting that this is such a solid and bold green. To display that this is a projection to the users, we could create a value called isFuturePeriod that determines if the period has started yet. And then, of course, we can conditionally gray out those values by saying that if it's a future period, we just want to use gray, whether it's positive or negative. And now we've got gray values running down the page for anything that is after, at the time of recording, May. We could even use this to add a little note at the bottom that says this balance is a projection. So if it's a future period, let's just say that it is a projected balance that considers rollovers that might happen. One more thing on the calculations. Like I said, it's currently May, so I would consider that my balance is somewhere down here. But if I'm at the top of the page, I actually see a positive balance. And that's because right now we're calculating this balance based on total funding and total spending for the entire budget. But if we plan to fund the budget each month, displaying that total at the top as the current balance kind of feels wrong. So I'll add a conditional function that determines which period is currently active. And tests for this will be on GitHub after the video. I know this is getting long at this point. So I'll just add this down here. And then pull in the current period ID into the assigns and use it to grab the balance directly in the show live page. So up here, instead of saying that the balance is the result of subtracting the spending from the funding, we can just say that the balance is the current period's ending balance. And now I see my negative balance, which should be accurate as of May. Maybe it's even more clear to say current balance. So at this point, we've done a lot. We've added a new period details view that holds transactions for a given month. We've proven the reusability of components like currency and the transaction dialog. We've calculated balances at multiple levels, tapping into database-specific functionality through the use of Ecto's fragments, and improved the user's experience by navigating them to the correct period when they work on a transaction. Next time, we're going to start sharing budgets so that users can collaborate. This has been Code and Stuff. Thanks for watching.